All right, we're back with the second installment of how to draw influence lines. All right, so this time we're just going to hit you with a whole bunch of examples. Feel free to pause the videos, get some scrap paper, and try and work it out yourself ahead of time. Okay, that's one of the best ways to learn. So I put the moment, the shear, and the reaction, the releasing and deforming steps up at the top right here. At the bottom, in word form, the Muller-Breslau principle. All right. Just 3 simple steps, really 2. Release the structure and perform a unit deformation. Done. You got your influence line, all right, in the form of the deformed shape of the structure. First one, we're going to do the reaction at B. Second one, we'll do the moment at the midspan of C and D. And then in the last one, let's do the shear on the left side of D. All right, so we hinted at this before, but the determinacy will affect whether we have curved or straight line segments, okay? This beam here is a continuous beam. It's indeterminate, so we're going to have curved influence lines, all right? All right, so first step, let's do it for the reaction at B. So number 1, release the structure. We take away the support at B. We push up until we have a unit deformation of 1. And now we draw our deformed shape, all right? So we're drawing it. We know it's going to be curved. And we know we have to respect the boundary conditions that are still on the rest of the structure at A, C, D, and E. All right, and this is the shape we end up with. We can label our spot here. We know that the deformation right at B is 1, which makes sense, by the way, right? If a load acts right at B, the force is going right into the support at B. So it's a 1-to-1 ratio. All right, second one, the moment, we'll introduce the hinge right here, midway between C and D. We're going to apply this moment, producing compression at the top, okay? Now that compression at the top of the beam, it's going to force the segments along the top to get smaller. So it's going to force the hinge to move up, and we wind up with this patterned deformed shape here. So between AB and CD, we have, if we put loads there, we're going to get a positive moment between C and D. And at the other 2 locations, we'd get a negative moment. Now we can label our angle change. So you can label it as 0.5 on both sides or an angle change of 1 altogether. Next, let's take a look at the shear to the left of D. So let's release the structure, apply that vertical roller seen in the top right. Now we apply a vertical force on one side and a vertical downwards force on the other. Get this unit deformation of 1. But we know that the DE can't change, okay, so it's just going to be flat. We need to match the angle on the other side of the vertical roller, so it's also flat, and we just see that the structure will still be anchored at A, B, and C, and it will deform like so. Excuse me. So we see that the shear release, the rotation is transmitted, but the shear is not. And in the case of the moment, the rotation is not transmitted, okay, but the shear is. So that's the difference between those 2 releases. All right, and we'll just label deformation of 1.0. Okay, so we're going to go a little quick here, but here's another 3 beams, very similar, except this time they're determinate. So we're going to have straight lines. We'll do the reaction at B, the moment at C instead of CD, since there's a hinge there now, and the shear to the left of D. So first, the reaction at B. And I'm not going to walk you through it here. You can just watch me do it. Try on your own if you can. But notice that because they're determinate, we can actually label all the points. We could actually get a quantitative influence line, it's called. And this quantitative influence line has an extra ability. It can actually solve for the actual value of the thing in question just using the influence line. So for this one, the moment at C, we can actually place a load and times it by the ordinate of the influence line to get the real moment at C. Okay, so that's how that works. And here's the shear to the left of D. And just note, whatever I've highlighted in yellow, it means that part of the beam was fixed. Okay, it had to be straight. And you can see that just logically based on the supports. All right, so for these last few, I'm not actually going to walk you through them. Just pause, try and do them yourselves first. I would really suggest that. And, play it back as many times as you need to watch how I do it. Make sure you're doing it right. And it's always possible that I make errors, so just, write in the comments if I totally screwed up. I'll admit it. I'm man enough to admit it. Yeah, so give them a shot. But the big thing here is repetition. You do this one time. You spend about 15-20 minutes one time, and you can just master influence lines for your whole lifetime, okay? Think about it as like potty training yourself or something, all right? All right. Happy structures. Happy structures. I suck at thinking of taglines. If you have better, let me know so I can stop embarrassing myself.